Good morning. We are on 13.1, page 725.
You know what's funny, Mr. Biggie?
What?
Carl's right there. So the rep form. The rep before you go.
Yeah. A, 3, 9. 3 is going to be right here. 9 is going to be right there. Okay, notice. Hello? What do the boxes go by? What's our grid today? 2s. Okay, so look carefully for the odd numbers. 3, 4. 3, 4. And again, 3 is in between two lines because things are going by 2s. And then C is 11, 4. 11 is on the x-axis. It's almost to the 12. And then 4 is easy to find. And then D is 11, 10. Good, 8, 10. Okay, so again, this is A, B, C, D. And here's our little tiny trapezoid. Did you guys know this was a trapezoid before I said that word?
If I knew that.
What makes something a trapezoid?
4 sides, but not all equal.
4 sides. There's something else about trapezoid. This is a trapezoid too. Hello? Two sides are parallel. Two opposite sides are parallel. A lot of times that's symbolized with arrows going the same direction. Okay, if you see that. Okay. Where are the parallel sides on this trapezoid? Left and right. Okay. Translate the trapezoid on the coordinate plane, graph the image, and record the vertex in the table. Translate trapezoid 15 units to the left for trapezoid A, B, C, and D. You can do that by translating 1 point 15 units. So here's 3. If I start at B, it takes 3 to get over here to this side, so I need 12 more. 2, 4, 6, 8, 10, 12. Oh, duh. 12 more would go to 12, huh? Okay, so I'm moving it to the left. I figured out it took 3 to get to this axis because these grids are going by 2, and it was on 3. So here's the new A and the new B. And now I'm going to cheat use my resources, right? I'm going to slide my little shape over to figure out where the other 2 corners were. Those were pretty easy to find, but I do have this shape. I assume they want us to use it for something. So it looks like this should be right about here. And that one was on the line up here, but straight up from the C. So that's going to be right about here. C prime, D prime. Translate the trapezoid 15 inches left, form that trapezoid. Graph the image, record the vertex coordinates in the table. So my new A is at negative 12 on the x-axis. Has the y-axis moved? No, because it just slid right on over. It didn't go up and it didn't go down yet. So if I look at A prime, D prime, the first thing that I can go ahead and do is put in the same y values. So the second coordinate in these orders pairs did not change because we slid it over. We're only changing where it is on the x-axis, so the first coordinate will change, but not where it is on the y-axis. So I look at A and B. They both have the same x-coordinate. What is it? What am I going to write right here? Negative 12. And they're one right on top of each other. Okay? So they're both negative 12. And then C and D are both going to be the same thing. What are they at? Is that what you were looking at, Brody?
Yeah.
Negative 4 and negative 4. Okay, now we're going to translate our trapezoid 12 units down. 12 units down. So I'll go back to our picture. I like starting with corner B, and 12 down is going to be easy because it's on a grid line. 2, 4, 6, 8, 10, 12. Take the A down 12. Well, let's take the C down 12 because, again, it's on the line. That's going to make the counting easy. 2, 4, 6, 8, 10, 12. Good. It should have lined up with the old B. So this is B prime prime, C prime prime. And now I'm going to slide my shape on over and use it to help me out a little bit. It's a tiny shape, and my fingers all of a sudden feel like monster fingers. Are you having that trouble?
Yep.
Okay, so I can kind of see where things need to go, but I can also count. So from the D, it looks like I go 2, 4, 6, 8, 10, 12. That's going to be right there. For me, it's knocking out the number 4, but that's not on the axis. That's just where the numbers are. And then this one wasn't on the line. Remember, these are 2, so it's halfway between. So I'll go over and then go down by half a box. This isn't a square, or a rectangle, it's a trapezoid. So maybe I should draw in the shape. Straight line, straight line, straight line, diagonal. Little bit of a diagonal. That's what this shape is. A little bit of a diagonal. Ladies, that test, you should not be talking over there, my friends. Okay? All right. So we got to do coordinates. A prime prime. And when I look at the coordinates, it's going to be similar to this second version of our trapezoid, or this image. Now, this translation was a vertical, straight down, and straight down only. That means that it's going to match these coordinates, but which ones? The x's or y's? The x's are going to stay the same this time. So whatever the x was here, I can just move it on over. The y's have changed, though, because we slid it down, and y tells you about things up and down. All right? So let's look up at the graph. If I'm looking at B, what's its B prime prime? What's its new y? The bottom trapezoid that we just created. If I'm looking at B, it's this one. It's negative 8. Yeah, probably would have made sense to do A, but for some reason I've been starting on B. So this is negative 8. Who else is at negative 8? Okay, so these two are in the same spot on the y-axis. Now, Jerry found A. A is down one whole box and half a box. That is -3. What's the y-coordinate for D prime prime?
-2.
Good job. Flip the page. Uh-oh, I lost my little trapezoid already. Where are you? Come back. There we go. Hold on to that little shape we cut out. Okay. Oscar, could you read number 3 for us, please?
Let's consider transformation without brackets. The vertex of parallelogram E, E, F, G, R, B, there's 9, E, there's 12,
So this time we don't have the graph to look at. They want us to just do this based on what we saw, or we're thinking about in a pattern of their vertices. So D prime okay. And the first translation they want us to do is 14 units down. What will that change? That's going to change the y. So I could go ahead and look at the x coordinates and copy them in. The x is the first of the two in each ordered pair. Now, we're going 14 down. What's that going to do with the y-coordinates? Subtract. So I have, for my first coordinate, 7. Well, if I subtract 14, that's like adding -14 to it. Andy, what's 7 minus 14?
7 minus 14 is 7, or -7.
Good, thank you. 2 minus 14. Thank you. Again a 2, so again a -12, and again a 7. So again a -7. This is a 0. How did you determine the image coordinates without graphing? Some of them we left the same. Who'd we leave the same? So we were changing the y's, and since we were translating 14 down, what did we do?
Subtracted 14.
Determine the vertex coordinates of the image of D prime prime E prime prime F prime prime G if the parallelogram is translated 8 to the right. All right, I'm going to walk around. You guys do